Hi, everyone, and welcome to the Natural World Weekly, the show where we learn about the wonder of our natural world through science and animals. My name is Avery. I'm a biochem student here at UIC, and every week on this show, I'll walk you through a bizarre animal and an interesting natural phenomenon. And you do not need to be a scientist to understand this podcast. I hope you all enjoy this week's episode. Today, we'll be talking about bugs that walk on water. And I'll be talking about the crazy behavior of water, like why hot water freezes faster than cold water, but maybe only sometimes. Our animal of the day is water striders. Water striders are bugs living in swampy pond areas in the US, and they use their tiny little legs to walk across water. You may have seen them before. They are pretty common in the US. They have many fun nicknames, such as water skeeter, water scooter, pond skater, water skimmer, puddle fly, and Jesus bugs, which is my favorite. They have 3 sets of legs. The middle is used as like a launcher. It's their main like speed generator. They launch it across the surface of the water. Their back set of legs is sort of like a steering wheel. They put the right one down to go left, and then the front set of legs is shorter, and they use them to grab and eat stuff. They eat dead bugs that fell into the water and are floating on the surface. They're often described as scavengers since they don't actually really like hunt anything that's living. Despite being on average 5 millimeters long, or for my freedom uniters, that's 1/5 of an inch. They can eat a wide variety of bugs. Their max is like they can eat dragonflies or horseflies, which are, massive in comparison. They usually, glide across the pond together in groups and they go scavenging together. However, what's pretty crazy to me is if times are really tough and they can't find enough food, they have been observed hunting and eating each other. Water striders aren't like an individual species and are actually a large family of a bunch of different insect species. Like how panthers and cheetahs and lions are all in the feline family. All of these, water strider species, except for one small group, live in, the swampy lakes and ponds, like I said. But there is a specific genus called halobates that actually live in oceans and are the only known ocean-exclusive insect out there. Instead of eating like dead flies and dead bugs and stuff, it's much worse, unfortunately. They find like dead floating fishes or like, mammals, whatever, and feed on them. So, yeah. Because they are incredibly resilient and kind of brutal sometimes, water striders are considered to be safe and not super notably impacted by threats like destruction of nature and global warming and all the stuff that has impacted pretty much all life. A little Avery lore for you. I grew up in a neighborhood with a small lake, and I remember seeing these bugs like jumping around the water and being, really interested in how they could do that and how like nothing else could. And honestly, they kind of annoyed me as a kid because I was jealous. Like, why can they do that and why can't I? So here I am giving the explanation. Water has a lot of properties and behaviors that make it such a useful chemical that's, so like essential to everything. And one of these properties is surface tension, which is basically how water is tightly packed together at its surface. You can actually like see this yourself by dropping water onto a coin, and if you go like by individual drops, you'll see how drops like tightly packed together onto the coin instead of just like immediately flowing off. It all pets together into like one big drop. And the reason why this happens is specifically about water's chemical structure. Every water molecule out there, it's composed of 2 small hydrogen atoms and 1 big oxygen atom, which is why people call it H2O. 2 hydrogen, 1 oxygen. The sort of structure to visualize of, two small things, one big thing. To me, it looks like a Mickey Mouse outline, if that makes sense. It's like two little ears attached to one big central thing. Looks like a head. The two hydrogen atom ears, they have a positive charge, while oxygen has a negative. Positive and negatively charged things are naturally attracted to each other, like how, negative magnets are pulled towards metals, and similar, magnets with similar charges repel from each other. So when you have a bunch of water molecules sitting next to each other, the positive hydrogens are going to be naturally pulled towards the negative oxygens from, its neighboring molecule, which makes the whole thing sort of tightly packed together and attracted to itself. Water essentially is magnetically attracted to itself, which pulls water tightly together and creates this surface tension. So then relating that back to water striders, they can actually sit on top of this tension, partly, because they're so tiny and they weigh basically nothing, but also because they have special tiny hairs on their legs that repel water. This repelling force helps them stay afloat on the tension rather than sinking into it as, they glide off of it. I think this is a super cool niche that the water striders have inhabited. They're so specialized to be able to walk on this water tension and use that to eat bugs that would normally not be really getting used by anyone. They are pretty cool, in my opinion. But if you want to learn more about water, specifically the reason why hot water may freeze faster than cold water, and the scientific controversy behind that, stay tuned for our next science segment. For our journey into the strange and wild properties of water, we'll be talking about the Mpemba effect. The year was 1963, and a high school student in Tanzania named Erasto Mpemba, which I'm sure I nailed, was begrudgingly working through his cooking class, where that day they were making ice cream. Now, when you make ice cream, at least in the traditional way, you combine the ingredients over heat, you let that mixture cool to room temp, and then you put it in the freezer. However, Mpemba was running low on time, so he just put the mixture straight off the stove into the freezer. And then he noticed something really weird. When he checked on the ice cream later, he noticed that his was freezing faster than the others, who all waited till their mixtures cooled down. If anything, you'd expect the opposite to happen, right? After seeing this happen, Mpemba was really puzzled and felt like he needed to show someone. So naturally, he went to his high school physics teacher and told him about what he saw. Honestly, like any other physicist or normal person for that matter, the teacher said, that doesn't make any sense. That's impossible. There's definitely something else going on here. Unfortunately, there wasn't really anyone else Mpemba could go to, so he just sat with this observation for a couple years and would periodically test it. His sort of big break into the physics world came when a British physicist who was working at a university in Tanzania at the time came to Mpemba's school to give a talk about physics. The story goes that when the physicist was done talking and started taking questions, Mpemba raised his hand immediately and asked about his observation. The direct quote given for what he asked is, quote, "If you take two beakers with equal volumes of water, one at 35 degrees Celsius and the other at 100 degrees Celsius, and put them into a refrigerator, the one that started at 100 C freezes first. Why?" Although it's said that his classmates thought this was a silly question and kind of made fun of him for it, the physicist actually later invited Mpemba to come to his lab and test his theory together, which I think is really cool. Unfortunately, the literature on the Mpemba effect is pretty all over the place. Some claim evidence in favor of it, and others claim honestly pretty solid evidence in contrary. It's definitely a pretty hot topic in the physics world. So, naturally, while I was writing the script, I decided to do a little experiment myself. I put 100 grams of water into two identical containers, One was at 20 degrees Celsius and one was at 60, and I saw which one froze first. Now, a tricky thing when collecting data on this is that it can be hard to tell exactly when stuff freezes, and I did definitely experience this with my, little at-home experiment. But I checked the temperatures 10 minutes in. There was no freezing, and the hot water was about 5 degrees hotter than the cool one. So the gap definitely closed quickly. Then I checked 20 minutes later. The two were at roughly equal temps, and I noticed some ice crystals forming in the hot water, while the cold didn't have any. As time went by, and I checked periodically, the cold water did start to form ice crystals, but the hot water was always, ahead of the game. And then when I finally took them out, the hot water was significantly more frozen than the cold. It was pretty much fully frozen, while the cold one was, maybe like half. I was super shocked by this, and it was pretty cool to see the Mpemba effect in my own freezer. I highly, highly, highly recommend trying it on your own, in your own kitchen, and seeing what results you get. So what are the proposed explanations for this? There are a couple. My personal favorite references back to what we talked about in the animal segment, which is that water, has positive hydrogens, negative oxygens, and water molecules attract to each other with these forces. Some people think that heat helps sort of break down and separate these forces, which in turn helps the molecule separate and slow down, which then, freezes it. Other people think that because hotter water / ice cream evaporates some while in the freezer, and thus, freezes faster because there's less water. I think this is a decent point. Just anecdotally though, in my experiment, my two waters look to be the same volume throughout the whole process, but who knows? So what's the argument against the Mpemba effect then? I said it's pretty strong. Well, for starters, no paper since the original findings published by Mpemba himself and the British physicist, no paper since has found as strong evidence as they did. It's either been, much weaker evidence or evidence against it. A really compelling paper against it came in 2016 from Cambridge that showed that their temperature readings differed drastically depending on where in the water they put the thermometer. If the thermometer was in the center, the hot water would be hotter consistently and the effect wasn't shown. But if the thermometer was put to the side even by just a centimeter, which for my freedom uniters, again, that's like 2.5 inches, the readings would be drastically different and the effect would be shown falsely. I did keep this in mind when I was doing my experiment, and I read that my temperatures in the center, but I mean, who knows what kind of effect this could have had. Plus, I wasn't using scientific grade equipment. I was just using a commercial food scale, commercial thermometer. So who knows? It's definitely imprecise. This phenomenon is still very much a contested mystery in the physics world, and there's no consensus on whether or not it exists. Even after, this was first discovered in the 60s. There's been decades and decades of research into this, but it is still contested, which I think personally is all the more reason why you should go measure out some water and try it for yourself. But that is all I had for this episode. Thank you all so much for watching this week's episode. I hope you enjoyed it. I think water starters and the Mpemba effect are super cool, and I always appreciate the opportunity to do some at-home experiments in my kitchen for the pod. I also love to do an episode where the two topics sort of, feed into each other. I hope to see you all next week. Reminder that all sources will be linked in the description. And until week, remember to stay kind and curious. And remember to do your own experiment with the Mpemba effect. See you all next week.